Now we are discussing about circuit switching and packet switching. In the circuit switching, there is an establishment of a dedicated path between the two computers. Means that the path is dedicated until the communication is over. These two computers can only use that dedicated path. Example, I am using D1 and D2. These two devices I am using. A dedicated path is established between D1 and D2. This dedicated path will be there until the communication between D1 and D2 is over. So example, if we have M inputs and N outputs, we are thinking that there are M source systems and N destination systems. We can connect a dedicated path between this first input of M and third output of N. This dedicated connection will be there until the communication is completed. Once the communication is completed, then this dedicated path will be removed. Then this will be allocated to some other user. Here, the telephone communication is working in the same manner. Example, I want to communicate with other person. When I am ringing a number, means when I am dialing a number, once the call is established, until the call is over, that dedicated connection should be there between the two users only. When the call is over, then only that dedicated connection can be allocated to the other user. But this is not efficient communication. Why this is not efficient communication? Because we are giving a dedicated line to it. Sometimes the two users may use and sometimes they might not use. Sometimes we may find the gap. That's why this is not an efficient way of switching. Here, throughout the session, the dedicated connection will be there, irrespective of whether the source is sending packets or not. It is not relevant. It only thinks whether the communication is over or not. When the communication is over, then only the connection will be terminated. That's why this is session oriented. Throughout the session, the dedicated connection will be there. But the circuit is very simple. That is the advantage, and there is no much delay. So this is the advantage. There is no much delay. But you can observe, in order to establish the call, there is a delay. Once the call is established, for the communicating packets, there is no delay. But in order to establish that connection, there is a delay. This is disadvantage. While communicating, there is no delay. While communicating the packets from source to destination, there is no delay. But before establishing of the communication, there is a delay. This is advantage. This is disadvantage. Here the delay is less. While during the communication, the packets transmission, here the delay, prior to the call, it will check whether this traffic, this particular node or this particular device is being used by any other or not. For that, it will take some time. This is the disadvantage, and it is inefficient. As we discussed, this is session oriented communication, and the channel capacity is very less. So that is also one disadvantage, because we are laying the dedicated path. Only those two can only use that dedicated line. We can send voice data, but it will not be suitable for, it will not good for using of the data communication here. It is not that much flexible. The flexibility is not there. We cannot send data, we can send the voice. These are the advantages and disadvantages with the circuit switching. Where we are using the circuit switching nowadays, we can use in the telephony. Okay, now we are discussing about packet switching. There is no dedicated path. So, for more time, whenever we are taking the establishment of the connection, we are sending the message packets. Means the message we are sending in the form of the discrete packets. These packets, there is no need to go in the single way. Like we are sending 10 persons to go to Delhi. One person may take flight from Vizag and he may go to Delhi. One person may go to train from here to Bhubaneswar and Bhubaneswar to Delhi. One person may go. One person may go to Vijayawada. From there he can take the flight to Delhi. One person may go from Vijayawada to Hyderabad through train, and from Hyderabad he may take flight to the Delhi. Even though it is appearing that all persons are going in different ways, but they are reaching the same destination. The paths may be varying, but they are reaching the same destination. Similarly, the packets we are sending, all these packets are only one message packets. We are sending all the packets of one message. These packets are being transmitted continuously in different routes, but they will reach the same destination. The packets may vary length depending upon the message what we are sending. This may be variable length. Here we are sending the data from source to destination, and from computer to computer, when we are sending the packets, one computer to the another computer will take the packet and it will act like a router. It will forward that packet to another computer, it will forward that packet to another computer. Like that, this process will continue. Now the question comes, if the line is busy, then these packets will be stored by the computer until the line becomes free. Once the line becomes free, then only these packets will be delivered through the line. For routing the packets, in which way these packets has to go, we simply mentioned these packets may travel in different directions. But on what decision, who is giving the decision to these packets to go in different direction? For that only we are using network protocols. These network protocols will tell the packets to go in which direction. That will be decided by the network protocols. In packet switching, mainly we observe datagram and virtual circuit. Datagram means source to destination, we are sending the packets in different paths. Whereas in virtual circuit, source to destination, we are using only single path. It is a little bit appearing like circuit switching. This virtual circuit, that's why the name is virtual circuit, circuit switching. Virtual circuit, virtually it is behaving like that only. We are thinking like there is a dedicated path established. Temporarily, source to destination, it will follow only single route, but all the packets will go with the single route. But here all the packets will go in the different directions. Here the packets will reach fastly the destination. Here definitely the packets, there is a delay, because one by one all these packets are moving. There will be delay definitely. These are the circuit and packet switching techniques. Now you tell, in circuit switching, we are taking the dedicated line between one device and another device. That dedicated line connection will be there until what time? Until the message is delivered, until the communication is completed. Until that, the dedicated line will not be terminated. Now, you see here, there is a telephone for the telephone communication, which switching we are using, circuit switching or packet switching? Circuit switching. In telephone communication, we don't, example, I am saying some sentence, I do not expect, yesterday we discussed, he ate apple. When we send through the packet switching, sometimes apple may reach first, apple ate he may come. Okay, so in the telephony, we generally use circuit switching only. So it is not efficient. Throughout the session, communication will be there. Delay is not there once the communication is established, but before establishing the communication, there will be a delay. Channel capacity is less and dedicated connection is there. Because of the dedicated connection, it is inefficient. We can send a voice. It is not flexible. In packet switching, we are using packets of variable length. We are dividing the message into different packets. We are forwarding these packets. This can be done either by using datagram or virtual circuit. In datagram, we are sending that packets to different routes. In order to tell in what route the packet has to go, there are network protocols. Depending upon the decision of these protocols, these packets will go in different directions. But finally, all these packets will reach the destination. In virtual circuit, from source to destination, the single path, all these packets will go in the single path.